Hi all, I hope that your paper one went okay. I'm just going to go through the paper two revision ahead of Thursday. So again, I'm going to go through the blue ones first, and then the green ones, and then the orange ones, just to build up in terms of difficulty. So remember, blue is aiming for a grade 4, and then green a 7, and orange a 9. So starting with congruent triangles. So congruent triangles just mean two triangles that are exactly the same. In terms of, you could cut them both out, and you can flip them over and turn them around, but they would fit exactly on top of each other, exactly the same orientation. Well, in terms you could fit them on top of each other, okay? So we need them to be identical. So here we've got some triangles, and we want to know which two triangles are congruent to A. So A is my triangle up here, and I can see that in triangle A, I've got 4.6 centimetres on this side here, and opposite, we've got 71 degrees. And then we've also got 64 degrees. And it might be helpful, let's draw in what we also know. We also know that if we add this up to make 180 degrees, because there's 180 degrees in a triangle, we've got 71 add 64, which is 133. And if we take that away, sorry, 135. And if we take that away from 180, it would be 45. So I can see that in this corner here, this angle here, would be 45 degrees. Now, that helps me because it means that I know that in any congruent triangles, the side that is 4.6 needs to be between the 64 degrees and the 45 degrees. So if we come over here and we look at B, for example, B is no good. B, the 4.6 is opposite the 64 degrees. That's not going to be congruent. That's not going to be the same. It's not going to line up. If we were to cut them both out and put them on top of each other, that wouldn't be the same. So B is no good. Let's have a look at C. C, the 4.6 side is opposite 71 degrees. And we've got 64 degrees here, and we'd have 45 degrees here. So I'm happy that with this triangle, it would be exactly the same as A. We could just turn it round and it would fit exactly on top. So C, C is congruent to A, and we need one more. So this one is no good because the 71 degrees is next to 4.6. That's no good. And same here, 71 degrees is next to 4.6. That's no good. So hopefully you can see that on D, this triangle here, we've got 4.6 down the bottom, next to 45 degrees and 64 degrees, and opposite the 71 degrees. So D is also congruent to A. So C and D would be my answers. These two are exactly the same as A. Now, if a shape's been made bigger, but is in the same orientation, we would call that similar. But if they're exactly the same size and shape, they would fit on top of each other, we call that congruent. So that's the first one. Okay, next we have a cumulative frequency table. So the table shows information about the number of hours that 260 students spent revising for an exam. And we've got two tables. The first table has 0 to 2, 2 to 4, 4 to 6 hours, and how many children spent how many students spent time revising in each category. So we can see there are 20 children that spent between 0 and 2 hours revising, and there are 32 children that spent between 2 and 4 hours revising, and there's 48 children that spent between 4 and 6 hours revising, and so on. For the cumulative frequency part, down here at the bottom, we've got 0 to 2, that's the same as we had here. So for that box, we can put 20. We know there are 20 children that spent between 0 and 2 hours revising. But when we go down to the second one, it's 0 to 4. So when we're trying to fill out the table for 0 to 4, we need to think about all the people that were in the 0 to 2 category and the people that were in the 2 to 4 category. So we want all of these people in both categories. So we're going to add on the next number. So 20 add 32 is 52. So that would go there. And then we've got 0 up to 6. And for 0 to 6 hours, we need all three of these categories. We need the 0 to 2, the 2 to 4, and the 4 to 6. Now, luckily for us, we already added on the 20 and the 32. So now I've just got to add 48 more. That takes us up to 100. Then we've got to add on 120. That takes us up to 220. Then we've got to add on 24, which is 244. And then we've got to add on 16, which takes us up to 260. And you normally just want to check that that number that you've got to is the total number of students, because it should all add up to how many students there were. So we've done it, 260, that's our cumulative frequency table complete. And that's the data that we're going to use to plot on the graph. Now, a cumulative frequency graph makes this kind of S-curve shape, because it's just going to build up and up and up. It accumulates, it just goes higher and higher and higher. So it makes that kind of S shape. And we can't plot in the middle because the sizes of the categories are all slightly different, and it would just look a bit bizarre. So we always plot at the top for a cumulative frequency table. So you're saying everything up to 2 is 20. All the students up to 4 is 52. All the students up to 6 is 100. So we're going to plot at this top end of the category. Okay, so plotting on the graph, we're going to go across to 2 and up to 20. Be really careful with the scaling of the axis as well. Here we've got 10 squares is 40, so every square must be 4. And we would divide by 10 to find out how much each square is worth. So we've got 20 there, and then up to across to 4 and up to 52. Now 52 is going to be 3 squares above 40, because that would be 12. Each square is worth 4, remember. Across to 6 and up to 100. Across to 8 and up to 220. Across to 10 and up to 244, which is going to be 1 square above. Just be really accurate with this, so you don't want to lose any marks. And then up across to 12 and up to 260. So that's there. And all we do now is join it up with a smooth curve. Now you're going to have to forgive me, because on the screen I'll be very surprised if I get this as accurate as if I was doing it on paper. Oh, it's going too well so far. This is too good. Oh, amazing. I'm impressed with myself. There we go. So that's our cumulative frequency graph. I'm just going to join it up with a smooth curve. Then it says, use your graph to find an estimate for the median. Now, the median is in the middle, the middle piece of data. We know that we asked 260 students how long they spent studying. Now, technically, the middle would be between the 130th and the 131st student, but because we've got so much data here, it's not really going to make a difference. So we're just going to read across at 130. So that would be 124, 128, 132. So it's going to be somewhere between those two. We read across here at 130. Again, I would use a ruler if I wasn't doing it on the computer. And then we go down and be as accurate as possible. I see that 7 is here, so that would be 6.6. I think we're going across in 0.2s every time. So the median is 6.6 hours, which makes sense because we can see that the data goes from 0 hours up to 12 hours. So that would be about right. And then it says, use your graph to find an estimate for the number of hours for the number of students who spent less than 3 hours revising. So for this, we would go to 3. Stop letting me draw on the thing. Okay, I'm going to have to just talk you through this one. You would go to 3 on the graph here, and we would go up from 3, and we would go across. And that is about 35. Now, that doesn't mean that, that does mean, so sorry, 35 students spent less than 3 hours revising. Those are the people underneath. If you were asked how many students spent more than 3 hours revising, we want to know how many are above that point. So if it was letting me draw, I'd draw a lovely line across to 35. So the answer for that question, how many students spent less than 3 hours revising, is about 35. Okay, but if I wanted more than 3 hours revising, I'd have to do 260, take away 35, so 225 students spent more time than that revising. So just be really careful if it's less or more. That's better. A football team has 2 matches to play. The probability that the team wins is 0.6. The probability that the team draws is 0.3. Complete the tree diagram. So they filled in the first bits for us, 0.6 and 0.3. Now, branches of a tree diagram, whether there's 2 or whether there's 3, are always going to add up to 1. We know that it's certain we're going to take one of those branches. So if this is 0.6 and this is 0.3, then the probability we're going to lose would have to be 0.1, because that would add up to make 1 whole, or 100% if you're doing it in percentages. So 1 whole. and the probability isn't going to change. They have 2 matches to play, and they're just as likely to win. It doesn't say anything about if they win, they're feeling super confident, and therefore they're more likely to do well again. So it's just going to be the same probability. So for the second match, there's a 0.6 chance they'll win, 0.3 chance they'll draw, and a 0.1 chance they'll lose, and so on. 0.6, 0.3, 0.1, 0.6, 0.3, and 0.1 for lose. That's the tree diagram complete. You want to make sure all your branches add up to 1. And yeah, that's done. So then it says work out the probability that the team will win both matches. So all you need to do is think about what happens down each branch. So if we want them to win the first match, then we want to go down that branch. And if we want them to win the second match, then we want to go down that branch. Now we times along the branches, and if we want more than one option, we would add those together. In this case, we just want them to win both matches. So it's going to be 0.6 times 0.6. So you're timesing along the branches. Now the most common mistake I see here is people tell me that's 3.6 because they're doing 6 times 6 is 36. And then they're telling me that's 3.6. Think very carefully. 3.6 does not make sense in probability. Probability, 1 is certain. So greater than 1 is can't be right. So 0.6 times 0.6, you've got 2 numbers after the decimal places in the question. So you're also going to have 2 numbers after the decimal places in the answer. So that is 0.36. And that makes more sense as an answer for probability. If I was asked what's the probability they win once, then you'd need to start thinking about winning the first one and then drawing, or winning and then losing, or drawing and then winning, or losing and then winning. So in that case, we'd have to multiply along all of those different branches and then add together all 4 of the options that we wanted. Okay, but in this case, all we wanted was for them to win and win again. So our answer would be 0.36 is the probability of them winning both matches. We don't care about any of the other scenarios or situations. Okay, question 10. Work out this multiplication of fractions. Give your answer as a mixed number. So with fractions, we want to make them both top heavy to be able to do it. To do that, we do big times bottom, add on the top. So the whole number multiplied by the denominator, add on the top. So 1 times 4 is 4, add 3 is 7 over 4, times by, and then 1 times 3 is 3, add the 1 is 4 out of 3. So notice that the denominator, the bottom number, stays the same on both. Timesing, this is the nicest one that they can give you. Adding and subtracting, we have to make the denominators the same. Timesing is just top times top and bottom times bottom, and dividing is keep, change, flip. So timesing, lovely. We can just do the numerator times the numerator and the denominator times the denominator. You do not need to make the denominators the same. So no one needs to be making this out of 12 because we're not adding or subtracting, we're just timesing. So we're just going to do the top times the top and the bottom times the bottom. So this is going to be 7 times 4, which is 28, and 4 times 3, which is 12. Now we need to say how many 12s go into 28. We could simplify it at this point. I'm just going to make it back into a mixed number before I do that. How many 12s go into 28? So 12, 24. So it's going to go in twice, remainder 4 out of 12. And we can simplify this bit of the fraction. So that's 2, and they're both in the 4 times table. So dividing by 4 is 2 1/3. And that's my final answer. All done. If I decided to simplify at this point, I could have said, well, they're both in the 2 times table. So I could make it 14 over 6. And that simplifies to 2 wholes because 6 goes into 14 twice. Remainder 2 over 6, which is 2 1/3 again. Or I could have gone from here and made it 7 over 3, which again is 2 1/3. So it wouldn't have made a difference whether you simplified it to begin with or after. But for timesing fractions, you want to do top times top, bottom times bottom. If they're mixed numbers, we're going to make them top heavy first. Okay. Number 11, in the diagram, AB is parallel to CD. So this line here is parallel to this line here. Work out the size of angle X. Okay, so let's just start by filling in what we know. Immediately here, I want to fill this one out because I can see that we've got a straight line here. So angles on a straight line add up to 180. So if this is 116, then this one is 64 degrees. And then that immediately gives me this triangle, and I know that angles in a triangle add up to 180. So I've got 51 and 64. So I would show my working. 51 add 64 is 115. And then I would do 180, take away 115. Now, if there's more on the floor, borrow from next door. So 10 take 5 is 5. 7 take 1 is 6, and 1 take 1 is nothing. So we've got 65 degrees here. Now, with these questions, if it says give reasons for your answers, you really need to write the reason at each stage. So I would say that angles on a straight line add up to 180. We used that. We also used angles in a triangle add up to 180. We also use that. And then how can I work out x? So because I know that both these lines are parallel, if I go round this angle and I go round this angle and I join it up, hopefully you can see I've kind of got that F shape. And I know that these angles would be the same. Now, if it's F, that's corresponding angles. So with my class, I often say corresponding and alternate, which I know makes absolutely no sense, but it helps me remember which one's which. So F is corresponding, and the Z shape is alternate angles. So because this is an F, we're going to say its corresponding angles are equal. So X is also 65. So I've got 65 degrees here. Oh, I'm clicking all over the place. Sorry. 65 degrees here. So X is 65 degrees because, and again, we're giving the reason, corresponding angles are equal. There we go. Okay, Hannah wants to estimate the number of eels in a lake. She catches and rings 50 eels. So this would be like a conservation thing where she's going to catch the eels and she's going to mark them with a ring. I don't know. And then she returns the 50 eels to the lake. The next day, Hannah catches 400 eels. Of the 400 eels, 10 of them are ringed. So what does that tell us? What does that tell us? So 10 out of 400 were ringed. And that would give us some indication of the proportion of the number of eels that she managed to get the day before. So if she caught 50 and let them go, and then the next day she's caught 400 and only 10 of them were ringed, what proportion is that? So 10 out of 40, let's simplify, it's the same as, sorry, 10 out of 400 is the same as 1 out of 40. So I've just divided the top by 10 and divided the bottom by 10. So what we're saying is she managed to ring 1 out of 40 of the eels, but she did 50. So if 50 is a 40th of how many eels there are, 50 is a 40th of the eel population. We don't know that for sure, but it's a pretty good indication. If she put rings on 50, then we know that there would have to be 40 times greater than that for that fraction to be about correct. So I would do 50 times 40. Now 5 times 4 is 20, and then add the 2 zeros on. So we think there's probably about 2,000 eels in the lake by those numbers. The other way you could have done it is, actually, it probably would have been a little bit easier if I'd have said, if 10 out of 400 was how many she managed to catch, that is 50 out of how many? And then you can just say, well, we've times the top by 5, so we would have to times the bottom by 5 as well to keep this fraction equivalent. So 50 out of 2,000 the day before. We wouldn't expect the proportion of ringed eels to change. We would expect it to be the same. So however many she caught and captured should be that fraction of the total, the same as the next day when she caught 400 and 10 of them had rings on. So hopefully that makes sense. So 50 times 40 would be one way of doing it, and just finding an equivalent fraction would be another way of doing it. So that's the capture, recapture stuff. And again, there's loads of Hegarty numbers on that if you want to have a look at the numbers there. So I don't know why it's on there twice, sorry. So 873 would be a good Hegarty number to go and practice that skill for that one. Okay, in a village, the number of houses and the number of flats are in the ratio 7:4. The number of flats to the number of bungalows are in the ratio 8:5. Now, this says that for every 7 houses, there's 4 flats, but for every 8 flats, there's 5 bungalows. So ratios is never the number of, well, it could be the number of flats or the number of bungalows, number of houses, but it's likely to have been simplified from a bigger ratio. So it says there are 50 bungalows in the village, okay, 50 bungalows. So I know that this here is 50. So the number of flats to the number of bungalows is 8:5. And the number of houses to the number of flats is 7:4. So if there are 50 bungalows, clearly this has been simplified. And we can see that it needs to be 10 times bigger, and we need to do the same to both sides to keep it equivalent. So there must be 80 flats, which is fine, but here we've got 4 for the number of flats. So I need to do something to this ratio to make sure that there's also 80 flats and keep it the same. Okay, we need it to be the same because the number of flats hasn't changed. So there must also be 80 flats in this ratio. What have I done to the 4 to turn it into 80? Well, I've multiplied it by 20. So I'm going to do the same to the 7. If I times that by 20, I've got 140 houses. So if there are 50 bungalows, there must be 80 flats. And if there are 80 flats, there must be 140 houses. So just remembering that we can make our ratios bigger as long as we do the same to both sides, and that will keep it the same. Okay, the cuboid and the cube below are placed on the floor. The cuboid has a weight of 60 newtons. The cube has a weight of 40 newtons. Which exerts a greater pressure on the ground? You must show your working. So which one gives a greater pressure on the ground? So we are going to have to look at the area of the face that is on the floor. That's going to be where that pressure is being given through. So for this, we need the pressure formula. Now, pressure, force, area is the triangle we need. So a little bit like the density one that we did on today's exam. Pressure, force, area. So pressure, force, area. The force has to be at the top. So we've got the weight here, and hopefully you can see that that's going to be the force because that force is acting downwards. So we've got the force is 60 and 40, and we want to work out the pressure. Now the pressure, if we cover that up and do the sum that's left behind, is the force divided by the area. Now if I wanted the area of this face underneath here, I'm just interested in that face there. So we can see that that face has an area of 8 times 3, so 24. So for the cuboid, I'm doing 24. Sorry, no, I'm not. I'm doing 60. That's my force divided by 24. And this is a non-calculator paper. Now, I'm allowed to use a calculator for this question because I've just found it online, just another one, but your numbers will probably be nicer, and so you probably won't need one. So 60 divided by 24 is up 2.5. And that would be newtons per centimetre squared. So for every centimetre squared, it's putting 2.5 newtons of pressure. And for the cube, what would the face be of the one that's on the face that's on the floor? That face is going to have an area of 4 times 4, so 16. So for the cube, we're going to do 40 divided by 16. I'm pretty sure it's going to be 2.5. Yeah, 2.5. So actually, they're exerting the same pressure on the floor. There we go. On that, what else was on that topic, that question? So it says pressure, but also you need to know how to work out the volume of a prism. So on a completely unrelated note to this question, if we wanted the volume of this cuboid here, let's look at the pink one on the left here. If I want the volume of this, volume is the area of the cross-section times by how far back it goes or by how tall it is. So we already worked out that this space was 24. So if I wanted the volume, I would have to times it by how tall it is, 24 times 2. So that would be 48 centimeters cubed if I wanted the volume, but I don't need the volume for this question, but it seems to be on your revision list, so just good to have that in mind. You can do 8 times 3 times 2. You could do 2 times 3 times 8. You could do 2 times 8 times 3. It doesn't make a difference with a cuboid, but it's going to be the area of the cross section times by how long it is. Okay, that's going to get you your volume. Okay, we've got direct proportion now. So y is directly proportional to the cube root of x. So I always like to start by writing this sentence with my algebraic symbol for direct proportion, with my symbol for direct proportion. So y is directly proportional to the cube root of x. And then with proportionality, we take that symbol and we change it to an equals and a k. So y equals k multiplied by the cube root of x. Now it says y is 1 1/6 when x is 8. So let's substitute those values in and then it will let us work out k. So 8 is x, so y is 1 1/6. I'm going to write 7/6 if that's okay, instead of 1 1/6 because it's the same thing. 7/6 equals k times the cube root of 8, which is 2. So 7/6 equals k times 2. And if I want to know what k is, I'm going to divide both sides by 2, which would be 7/12. So if I divide this side by 2 and divide this side by 2, I'm just going to double the denominator instead of actually halving the top in that one. So k is 7/12. So I've got y equals 7/12 cube root x. That's my formula. Then it says find the value of y when x is 64. So all I'm going to do is substitute the 64 into my formula, and I've got y equals 7/12 multiplied by the cube root of 64. The cube root of 64, of course, is something times something times something that makes 64, and that's going to be 4. 4 times 4 is 16, and 16 times 4 is 64. So 7/12 times by 4. Now, if I actually want to times that fraction by 4, I'm just going to times the top. I don't want to times the top and the bottom because that's just going to get me an equivalent fraction. So that's going to be 28/12. We've had that fraction before today. 12 into 28 goes twice, remainder 4 1/12, which is 2 1/3. So that would be my final answer. Okay, the region R, shown shaded in the diagram, is the region between two circles with the same centre. So we've got a bigger circle and we've got a smaller circle, and the shaded grey bit is the area that we want. Now, the outer circle has a radius of 2n add 6, and the inner circle has a radius of n-1. All measurements are in centimetres. The area of R is greater than the area of the circle of radius n add 13. N is an integer, so a whole number. Find the least possible value of n. You must show all of your working. So I know that the big circle is going to be, well, let's start with the area of a circle. So area of a circle is pi r squared. So we should know that. So we've got pi r squared. So I know for the big circle, let's start with the little circle, sorry. The little circle is going to be, so small circle is pi times n-1 squared. So to square that bracket, we're going to need to write it out twice. So it is pi times n-1, n-1, because we're squaring it, we're timesing it by itself. So n squared minus n, add 1. That would be n times minus 1 times n, and minus 1 times minus 1. So n squared minus 2n add 1, and we're going to times that by pi, and that's the small circle. Now the big circle is the same, but it's pi times 2n add 6 squared. So we're going to need to square this. So again, I'm going to write that as pi times 2n add 6 times 2n add 6. And then afterwards, we're going to need to subtract the smaller circle, just so we're just left with the grey bit. So 2n add 6 times 2n add 6 is 4n squared, add 12n, add 12n, so 24n, add 36. And that's multiplying by pi. So that would be the whole circle, but we also need to take off the inner bit. So let me go down here, see if I can. So it says, we know that the big circle is pi lots of 4n squared add 24n add 36 minus pi lots of n squared minus 2n add 1. And the small circle is just this one. So if I actually want to subtract this, I can do it. Because they're both timesing by pi, all of the terms are going to be the same. So the big circle is going to simplify down to pi lots of 3n squared, because we're taking away an n squared. And then minus 2n is going to add 2n. So add 26n. And then 36 minus 1 is going to be 35. So that's the area of my big circle, not the big circle, sorry, just the grey bit. The area of the big circle, which is this, pi lots of 3n squared add 26n add 35, is bigger than the area of a circle of radius n add 13. So to get the circle of radius n add 13, it's going to be pi lots of n add 13 squared. So I'm going to write that out twice again. So working this down, I've got pi lots of, and I'm just going to leave this side as it is greater than pi lots of n squared add 13n add 13n, so add 26n add 169. Okay, I'm going to divide both sides by pi because it's an inequality, so I can. And then I'm going to take away n squared from both sides. I'm going to take away 26n from both sides. And that let's do that first. So that leaves me with 2n squared add 35 is greater than 169. And then I'm going to take 169 away from both sides, which is minus 134. So 2n squared minus 134 is greater than 0. Because I don't need the negative value because it's a positive length, isn't it? Right, so let's just make it 2n squared is greater than 134. Come on, be a nice number. Cool. N squared is greater than, so I'm dividing by 2, 67. I think 134 divided by 2. Yeah, 67. So n, if we square root both sides, is greater than, I'm assuming this one, was it a calculator question or no? No calculator. Okay, so we know that n has to be greater than the square root of 67, and it says that n is an integer. It said that n was a whole number. So what is the biggest whole number that is bigger than the square root of 67? So we know that the square root of 64 is 8. So 8's no good. That's going to be too small. So 9 is going to be the first number that's acceptable. So my answer for that would be 9. It's not letting me scroll up now, which is really unhelpful. So 9 is my answer for that one, even though I can't write it down. Okay, last but not least, we are rationalising. So to rationalise means to get rid of the third from the bottom of the fraction. So in this case, to do that, we need to times by that third. So we're going to times the fraction by root 11. But if we times the bottom by root 11, we also need to times the top by root 11. Now, when you times a third by itself, it just becomes the number. So root 11 times root 11 is obviously root 121, which is just 11. And then on the numerator, we've got 22 lots of root 11. Cancelling that down, we get to root 11. So that's our final answer. So that's equivalent, but we've just rationalised it. Now, slightly trickier is when we've got two terms on the denominator. We've got a third, and we've got another, a constant in this case as well. Now, to get rid of that, what we need to do, let me rewrite the question, is multiply by the conjugate, which is the same, but the opposite. So I'm going to multiply by 2 root 3, add 1, and 2 root 3, add 1. Put it in brackets if you find it helpful, because remember, we're going to need to multiply all of these terms together. So for the numerator, I've got root 3 times 2 root 3. Now remember, the root 3 and the root 3 are going to make 3. So 2 times 3 is 6. And then root 3 times 1 is just root 3. So I've just done this times this and this times this. And then for the denominator, we've got 2 root 3 times 2 root 3. Now 2 times 2 is 4. And root 3 times root 3 is 3. So 4 times 3, we're going to get 12 from that. And then the beauty of doing this is that if we do 2 root 3 times plus 1, we get positive 2 root 3. And if we do minus 1 times 2 root 3, we get negative 2 root 3. And so those two things are going to cancel each other out. So you don't even need to write it. I'm going to write it. We've got plus 2 root 3, minus 2 root 3. And that's happened for a reason, because we set it up that way. And then we've got minus 1 times 1, which is minus 1. Simplifying all that down, we've got 6 add root 3 for the numerator over, these guys are going to cancel, and I've got 12 take away 1, so over 11. And that is now in the form that they wanted, and we couldn't simplify that anymore. That's done. And I think that's it. Yeah, fabulous. Good. So hopefully that's been helpful. Again, if you want further practice on any of the questions, use the Hegarty numbers that you've got there, and also you should have that revision list available to you elsewhere as well. Thank you very much, and good luck for your next assessment.